Okay, so chapter 8 is about coding theory. Yeah, coding theory. The objective is coding theory. It has something to do with the, what is it called? The research on cryptology. Yeah, okay, cryptology. If you remember, it's very interesting. I have some students doing or did PSM on coding theory and cryptology. I remember one, he's now a lecturer, already finished his PhD in UK, but he started studying about numbers in the book, the code. You know, we have ISBN, right? International Standard Book. Look at the back of the book. Do I have any book here? Wait. Okay, I have this book. This is a good book actually. Nampak. Oh, apa yang saya tulis tadi? Orang tak nampak. This book is nice. Okay, at the back, alamak ada harga lah pula. Harga pun nampak. There's this ISBN ya, yang ada bar tu. Okay, actually, that is coding. Okay, there are some coding there that the last digit is like the sum of the first few digits and so forth. Okay, so that's why this is mainly used by computers and also mathematics. So if you just Google and look at cryptology, coding theory, so how people transmit confidential information from a place to another place using binary code. So binary codes normally is zeros and ones. Last week, I was watching this one movie that, so many movies actually that shows coding and embedded the mathematics in crypt analysis. So how do you transmit, like long time ago, they have Telegram, right? Now our Telegram is different. Our Telegram is like WhatsApp, but many years ago, Telegram is the one that they type, right? And then they give like, during one day, you get Telegram, like must be a very important news. Normally kematian lah, unfortunately, about Telegram. So they use this. And we have to have a message in the coding, yeah? So they will put some messages in terms of we write using sentence, right? A, B, C, D, E, but they turn it into numbers. And these numbers are turned into binary codes. So they have sequences of zeros and ones. So you will need to Google, go around and learn about sequences of zeros and ones, okay? And you will see words which are not English words, but words from zeros and ones, alphabets. If you visit my website, right? I'll give you my website, right? Or just Google my name. It's something like people.utm. If you visit my website, you'll see, you go to the left, go down at the publication, you will see some papers on splicing system. Actually, Shiham here is also doing something related, in which how you translate the DNA. So we do research we call it DNA computing, in which you know that we have all this long string, right? If you Google DNA, all this long string, how do you model in mathematics. So there's so many applications on this, and we are doing sequences, we're doing words, we're doing alphabets, and when we translate into some of the things that we learn in this class, then we have the, later on they have the automata diagram, all this kind of thing, which is very, very interesting. So if you interested for later, your even PSM can do all this if you like discrete, and there are so many applications. Yeah, I'm not going to go into all this, but I'll just go straight to our example, right? So let X be a word. So words means all these strings, zeros and ones. So I just follow the one in the notes, yeah? 0, 0, 1, 1, 0, 0, 1. You remember in the previous chapter, we talked about input, right? In the finite state machine. So those kind of inputs are these strings, like a word. Then if you repeat this word, then it becomes a code for us, right? So I translate or I transmit to you. If I give you this, then you repeat, yeah? Right? And then we don't transmit the original. This is secret. This is a secret, right? But if you are told that it's actually repeated word somehow, then you will just read this part. You don't read all. Okay, then you translate back. And if you repeat alphabet, this is repeat the word, yeah? Repeat the word. We can also repeat the alphabet. So how do you repeat this alphabet? I want to repeat 3 times, yeah? I want to repeat the alphabets 3 times. This is the alphabet, okay? So I repeat the first alphabet 3 times. I repeat the second alphabet 3 times. I repeat the third alphabet 3 times. I repeat the last alphabet 3 times. Okay, so the one that you don't tell people is actually repeating the alphabet 3 times. So when you get this whole one, how do you break the code? You break the code by dividing each alphabet into 3, right? So you just divide into 3 because you know you do it 3 times. Please. And then you just take the one of these, right? So from from the first one, you just take 0, 0. From the second one, you take 1, 1. From the third one, you take 0, 0. From the last one, you take 1, 1. So from that, you get back the original one, right? If we are told that it's just repeating the whole word and it's double, you just take this and you get the original one. So these are types of coding theory that we have. Okay, now I want to go to a definition of a weight. Not our weight, this weight is a different weight. Okay, definition 8.1 weight. Mathematics is a little bit weird, right? You defining things that is different from English, but it's okay. We can define something new, okay? For X in Boolean n, X is a word, in Boolean zeros and ones, to the n means it's an n tuple. The number of ones in X is called the weight. Of X and is denoted by X. Okay? For this one, 1, 2, 3, 4, 5, 6, 7, 8. So N is 8, yeah? Because there are 8 of them in the N. Okay, Farhan, are you here? Farhan?
Yes, Prof.
Okay, what is the weight of X? Jangan bagi saya 60 kilo, Count the number of one. How many ones?
4.
Kacang goreng pun susah nak kunyah kan? Okay. Usama, you still here? Usama? Ya, susah tak ada muka ni. Okay, next is Nurin. Nurin Shazwani. Nurin?
Yes, Prof.
Yeah. What is the weight of X?
4.
Ni panjang ni.
Oh, 8.
Because we double, right? It's just actually double. Okay. Dengar suara je ni sebenarnya. Shazwani. Shazwani. Nama dia hilang E.
Yes.
Okay. How many? How many? Ni aja darat 3 kan? Because we by 3.
12. Okay.
Okay, so that is what we mean by the weight, right? So if you have to find the weight, meaning you have to count the number of ones. Okay. Relax lah, you only stress saja. Salah pun tak apa, it's okay to make mistakes. Okay, right. Kalau tak nak nama dipanggil, kena on video. Saya tak panggil. Okay. Next. Next is what we call a parity check. Okay, parity check code. Now, this special coding, there is a name, right? Parity check code. So what we do, if we want to add another digit to the word, okay, we add another digit to the word. So if we have F from BM, then we want to add another one to the word, yeah? Is called the parity. Then sometimes people want to add this to the definition, m plus 1, check code. Okay, this is the original one, yeah? The word in the m, binary to the m, is called the parity m to m plus 1 check code with this condition. Okay, if B1, B2 until BM, like zeros and ones, right? Okay, in BM, okay, from here, we define F. Oh, I have to put B, right? If B, yeah. Okay. F of B, okay, this one, I want to add one more. Add one more. Okay. Where? All right. This bm plus 1, it depends on the weight of b. Okay. If the weight of b is even, the original b, if the weight is even, we add another 0. Okay. If the weight of b is odd, we add 1. Okay. Now, we look at an example. Okay. I will erase this one. This is senior notes, yeah? Okay, the question will be, construct a word code using the parity check code. Okay. Number 1. B is 1101. What is f of b? You can write in the chat or you can unmute. So you have to count this, right? Shafika Shohaimi. What is the weight? Shafika? Shafika, ada ke tak?
Yes, doctor.
Count how many one?
3.
How many ones? 3, yeah? 3. Is 3 odd or even? 3, is it an odd or even number?
Odd.
Odd, okay. Odd, you have to add 1.
1.
Okay, so add another 1. This is the original, just add 1. Clear? Shafika, is it clear?
Yeah.
Then you
Okay.
try another one.
Okay.
Okay, B is 11101. Okay, what is F of B? What is the weight of B?
4.
4. 4 is
Even.
so we add
0 on
0. So this is
111
11101.
010.
0. Senang je kan? Okay. Next. Tapi kena ingatlah kan, nak tambah. If it is even, you add 0. If it is odd, you add 1. Even this number is matching, right? 0 is even, 1 is odd. Kan? That is how I remember. Okay. Now I give you another question. You give me FB, anyone? You can type in the chat. Last one. Okay, so this one you add, because this is odd, right? Odd, add 1, yeah? Okay, this one, 8, yeah? It's 8, so you add 0. Okay. Okay? Okay. Adalah nampak 1-2 jempol di situ. Alright. Quite straightforward, right? The third thing that I want to put here is about the Hamming distance. Okay, the Hamming distance. Okay, so I write the definition 8.3. Let X and Y be words in BM. Cabut. The Hamming distance. Okay, so we have two words, yeah? X and Y, words in BM. So the Hamming distance, we call it H of X comma Y. Okay. Between X and Y is the distance. The Hamming distance HXY between X and Y is the, no, I don't want the distance, is the weight. Is the weight. Okay, is the weight of X plus Y. I haven't introduced what is the X plus Y. Okay. All right. Now, to write X plus Y, let me write a table. Yeah. So suppose this is the table of X is 0, Y is, let's say X is 0, X is 1, Y is 0, Y is 1. So how do we add this pair? Because this is a pair of 0, 0, 0, 1, 1, 0, 1, 1. Okay. Now when you add this, we want just zeros and 1. Okay, 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 0. So this is what you have to make sure to remember. 1 plus 1 is 0. All right. So we want to find the Hamming distance in between two words X and Y, but you have to add them first. Add in the sense of this is how you add. Okay. Now, there are reasons why we want to find the Hamming distance, but the application is later. Okay, let's start with some examples. Okay, the question would be, find the Hamming distance between X and Y. Okay, now the first one. I just follow here, yeah. 1, 1, 0, 1, 1, 0, 0, 0, 0, 1, 0, 1. Okay, the Hamming distance in between 1, 1, 0, 1, 1, 0 and 0, 0, 0, 1, 0, 1. This is equal to the weight of 110,110 plus 0,00101. Okay, you can write like when you add top and bottom, but you can just match and add the first, the second, until the rest. So this is 1 plus 0 is 1, the second one, 1, the third one, the fourth one, the fifth one, the last one. Okay, the last one. Okay, or you can write like this, yeah? 110,110, you want to add with 0,00101. This is much easier to see, yeah? 1 plus 0, 1, 1 plus 0, 1, 0 plus 0, 0. 1 plus 1 is 0. Okay, 1 plus 1 is 0. 1 plus 0 is 1. And 0 plus 1 is 1. So this is the one. When I do it just now, I just add, like, just look and add. But sometimes you don't see the right position, right? So, call one name again. Zurin. Tak panggil ke Zurin? Zurin. Yeah, what's the answer?
4.
4. Okay, that's it. That's the Hamming distance. So you are given words X and Y, and then you have to add, and then you have to count how many ones, and you get the answer. Okay, there are some other examples that I give. Later on, we'll go to the examples also. But I want to introduce another definition, yeah, which is the minimum distance. Okay, the next definition is the minimum distance. Okay, so for the minimum distance, you have to find all possible distances and find the minimum. Okay, the minimum distance of, we call it encoding function f from, I wanted it to be from Bn to Bm or Bm to Bn. Okay, Bm to Bn, okay, is the minimum distance, between all these things. This thing is different pairs. This thing means different pairs of code words. Okay, so you have to find the distance, and then you have to find which one is the minimum distance. All right, now and the distance is also known as the weight of this particular words, yeah? All right. Okay, so let's try. The question would be determine the minimum distance. Determine the minimum distance for the following code words, yeah? Okay, so you'll be given f of 0, 0 is 0, 0, 0, 0. F of 1, 0 is 0, 0, 1, 1. I think I will need 5, yeah? F of 0, 1 is 0, 1, 1, 1, 0. And the last one is all, okay, all 0, 3 at the end, this. Okay, now to find the minimum distance, we have to find the distance or the weight of every pair. So you will do everything by itself, okay, by itself. And then you have to do here and here, 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 here and here. All right, so there will be 3, 4, 5, 6 times, yeah? So what you will do is you find the distance in between any two. We normally don't use this one because the minimum distance for this, adding to this is just itself, right? Okay, but we just take one of this, it will be the same thing, right? So the first one. The second one, you don't do anything, right? This is just, okay, the first one and the second one. The first one, third one, just the same. The first one and the last one. Okay, so we take this, this, then this second one with this one, second and this, second and last, and then this one last. Oh, last one, yeah. Okay, so this one you add. The first one is 0, the second one is 1, the third one is 0, the fourth one is 0, the last one is 1. So you get 3. This one, you change this, yeah? This is all adding ones, right? So you will just change because when you add 1, you change. So 1, 1, 0, 0, 0. This is 2. And last one, again, you change this because you're adding 1. So it's 1, 0, 0, 0, 1. So this is 2. Then you will say that the minimum distance is 2. That's your answer. Okay, so the answer is the minimum distance is 2. Okay. Actually, why do we need a minimum distance? Because I will give one theorem and stop. Okay. There is this theorem that I want to share before we stop. This is important. One reason of finding this minimum distance is this theorem. Theorem 8.1. And an encoding function f from Bm to Bn can detect k or fewer errors if and only if its minimum distance is at least k plus 1. At at least k plus 1. That is D minimum, okay, at least, yeah, at least mean it has to be bigger or equal to k plus 1, or k is less or equal D minimum minus 1. So this theorem will give us the errors that this encoding function will detect. After we find the minimum distance, okay, or the weight of this, then we can figure out how many errors that this will detect. So for this case, we add another question just now to our problem. Question would be, how many errors will F detect? Okay. So from the theorem, the errors k will be less or equal to 2 minus 1, which is 1. So the answer is the code will detect at most one error. The code will detect at most one error. This k must be less or equal to 1. Either there is no error, 0, or there is one error. Okay, that is from this theorem. Okay. All right, guys. Tomorrow I will finish up this chapter with group codes. Okay, and also the last part will be decoding and maximum likelihood technique. Okay, this is very closely related to the quotient group that we have from the previous chapter. Okay, and then I'll give you your quiz. Then we're done for tomorrow, our last day of class.